So in this example, we have a significant amount of information. Much of it may be useful, some of it may not be. Some of it we may have to use in a side step beforehand in order to figure out what we need. Here's what we know. 3 meters separates a trough and a crest. Now you may think that this is the wavelength directly, but it's actually not. If we look at the wave, let me actually draw this out to get a visual on it. The wave will do something like this. And what we've been told is that 3 meters separates a trough and a crest. So a trough is here, a crest is here, and that distance is 3 meters. That is not actually the wavelength. The wavelength would be from trough to trough, or, based on the diagram I have, crest to crest. So, because waves are symmetrical, and the distance between any trough and any crest is the same, we also know that this distance over here is also 3.0 meters. So looking at that from crest to crest, we know that the wavelength of this wave is actually 6 meters. We've also been told that we have 12 crests, and a crest is the same as a cycle. So we have 12 cycles, and we know that 20 seconds have gone by. That is not the period. The period would be the length of time for one crest. This is the length of time for 12. So this is just how much time has gone by in total. We're being asked to calculate how fast the waves are moving. How fast? The speed, so v. So things change slightly when we're looking at the equation here. Now we need to look at this from the perspective of, what do I need to find? I need to find v. What equations have v in it? Only one, v equals f lambda. We know lambda, 6.0 meters. We don't know f. So this is the point where we need to look at the other information we have. Do we have enough information to find f and then go to v equals f lambda? The only other useful equation to find f would be f equals cycles over seconds. We have both. We have 12 cycles in 20.0 seconds. That calculates out to 0.6. This may not be a final answer, but it's the end of a calculation, so we do need to look at sig figs here. We use 12 and 20.0 to get here. 12 has 2 sig figs, 20.0 has 3. Final answer then needs to have 2 sig figs, so we'll add a 0 onto the end, give us 2 sig figs, and f, frequency, measured in hertz. This now gives us all the information we need to find v, because v equals f lambda, f 0.60, lambda is 6.0. That calculates out to exactly 3.6. Again, looking at sig figs, the numbers we've used both have 2 sig figs, 0.60, 2 sig figs, 6.0. That 0 is significant. It is after the decimal at the end. So we should have 2 sig figs in the final answer. Works out nicely. Last thing we need is units. V, speed, measured in meters per second.